Okay, so yesterday we talked about the classifications of polygons, the different names that were involved with a polygon. So, zoom in here. Perfect. All right, so we talked about triangles. We talked about quadrilaterals, those are four-sided figures. We talked about pentagons, which are 5. Hexagons are 6. We talked about heptagon or septagon. Octagon is 8. Nonagon or ninegon is a 9-sided polygon. Decagon, hendecagon, or 11gon, and then dodecagon. Now remember, if it's any type of polygon, you could call it, a 3gon, right? Because it's how many sides, so like a 9gon, 11gon. But I prefer that you use specific names, especially on the test. There's a portion which we're going to see today, because we're doing the second half of your test today, the practice guide anyway. You're going to have to use these words. So these are words you need to know. You also need to know the words we talked about yesterday, which is convex or concave. You have to know which one's which. We'll look at other words like equiangular, equilateral. We'll look at those terms that apply to these polygons. But these are the names you need to know, all 10 of these. Is there any questions on the basic nameage, what the names are? Again, these are polygons. There's no curved edges. We're not talking about circles here. Straight walls. You can see the pictures of them. Okay, if they're regular, we talked about the word regular yesterday. Regular means that it's equilateral and equiangular. Well, equilateral is all sides are equal. Equiangular is all angles are equal. It has to be both to be regular. Some of these pictures I've actually provided you are regular. This one's definitely not, that one's definitely not. You can see that not all 4 walls are equal to each other. So not every picture has to be regular. You gotta be kind of cautious of that. All right. Is there any questions with the 4 words we did, Tuesday? We have new words. We need to talk about the triangle today. So when you classify the polygons by its number of sides, so triangle is a 3-sided figure, right? It's got 3 vertices. Vertices is that plural word for the corners, the corner pieces. They label them with capital letters, all that good stuff. When we get to the triangles today, we're talking about the basic terms. There are 7 words you could use for a triangle. Now it seems weird, 7 words that you could describe a triangle. 3 of them always have to, every time you look at a triangle, there's always 2 words that go with every triangle, 2. And we're going to try to describe how do you know which 2 words to pick. Okay, so when you talk about a triangle, there's 2 ways to describe it. By its side lengths or by its angle measure. So those are where the 2 words always come from. So you can kind of look at my picture, and if we were to measure the walls, we could pick out a word that would go with it. And if I were to measure the angles with your protractor, we could also name it by its angles. The goal today is to learn those names, so you know specifically what type is it. Now, do I expect this to be perfect? No, but I expect you to at least study them, and you probably already know them, you just don't even realize it. Okay, we'll start with side lengths first. We'll get to the 3 words there, and then there's a weird middle one that goes in between these, which I'll explain later. But side lengths, there's 3. Angles, there's 4, and that's that weird one that goes in between. All right, questions at all about what we're going to do here? I'm going to go through this really fast because my goal is to get through these names, like clicking through, and then we're going to get to your practice guide. Does that make sense? So we got a tall order. I'm going to be flying here. You ready to go? Side lengths. Okay, by side lengths, the first word. If all the walls are different, it's called scalene. That means all walls are different. How they can denote that on a picture, they can do this. They can put the little hash mark, so every hash mark is different. That means all 3 walls are different. It's called scalene. Now, if 2 walls are equal, that's called isosceles. Isosceles. I spell it wrong quite a bit. I always forget that second little S. But isosceles. That's where 2 walls match. And you can see, like if the picture is isosceles, they have to mark it that 2 walls are the same. The third wall can be random. It can be different. It can be bigger, smaller. It doesn't matter. It's just different than the other 2. Now, the isosceles triangle is something we're going to study more in I think it's chapter 8 or 9. Because again, we bounce around a lot when we get to the triangles and stuff. That one specifically has a lot of properties that are involved. Last one is equilateral. All the walls are equal on equilateral. In fact, I can't even see it, but when you zoom out here, maybe you can better if I zoom there. Equilateral. All 3 walls are different. So any triangle you have, you can give it one of these 3. So you can, if you measure the walls, you can tell. Questions on the 3 words? Pretty straightforward. I think most people actually know those words, they just kind of forget which one's which. But you've usually heard that before. The equilateral triangle is actually a regular triangle. We'll explain the reason why it's regular. Because regular has to be equilateral and equiangular, and that's that weird middle term. Because on a triangle, this is the only shape that does this. On a triangle, if you know it's equilateral, it's automatically equiangular. The angles have to be the same. There's some math that's involved there, which we're going to do later. So it is a regular picture. And all the other shapes, like a quad, pentagon, hexagon, octagon, if it's equilateral, it does not have to be equiangular, because the angles can be different, but the walls can be the same. But the triangle is the only one that is actually forced to be regular. All right, the other words. Get rid of those marks. If you're going to classify it by its angles, it could be an acute triangle. All the angles are less than 90. You can look at a picture and know instantly that they're less than 90. In fact, you guys always have the luxury that you can like turn your pictures, because you can turn the book and look at each angle side by side. Because most people, they can kind of tell when they look at an angle like this, or it's side by side. But this one can be tricky, so you can turn the book and kind of look at it from the side profile. So acute, all angles are less than 90. If one of the angles is 90, it's called a right triangle. One of the angles has a box in it. Those are the triangles. It's a right triangle is the most used triangle in math, because we do trigonometry, the study of triangles. We basically focus on right triangles the whole entire time in trigonometry, or pre-calculus, if you want to call it that. So right triangles, there's a ton of properties, tons of things we can do with it. And then the last one on the angles, but there's this weird bonus, weird one in the middle, is called obtuse. That's where one of your angles is bigger than 90. So it's obvious, like when you're picking angles, acute, right, or obtuse. You already know those. Those are the terms for angles. But only one of them has to be obtuse. You can see it like this is the obtuse angle. It's bigger than 90, past the L shape. If I were to turn that picture over, most people would struggle to see that obtuse angle. But putting it like that, it's obvious. It's past L, past the L shape. Now the other word that we have that's not on the slide is called equiangular triangle. Equiangular. Equiangular triangles are triangles that are equal for all their angles. Well, what you're going to learn later in like chapter, I think it's like chapter 4 and then chapter 8 and 9, there's a couple chapters that go over triangles. If it's equiangular, it's also equilateral, and it's also regular. But that only applies to triangles. That happens to be that way. But that's that weird floating word in between. So there's 7 words you can describe a triangle with. It means all angles are equal. Alright, questions at all about triangles? Okay, let's talk about the quads. There's tons of different types of quads. We're going to go into these more later. We'll come back to this PowerPoint. I'm not joking. Like, we come back to this PowerPoint in like the end of chapter, I think it's like chapter 3 or 5. It's one of the two. We come back to this PowerPoint and we do it just for the quads again. Because every time we go to a new shape, I come back to this and refer to the definitions before we start. So it's kind of like a review. We do it a lot. So, all right. So a quad, meaning 4, right? 4 walls. 4-sided, 4 vertices. Now, quads are a weird, is that me? Jeez, not me. It's top one. All right. For quads, they don't have to be a subcategory. They don't have to be a subcategory. They can be. There could be special cases, special names. But if it's just a random 4-sided figure, it's just called a quad. It doesn't have to be called another name. Some people get so thrown off at that. Like, well, what if it's a rectangle? That's a special case. Not every picture of a quad has to be a rectangle. They can just be quads, or quadrilaterals. Okay, but when you name them, there's actually 2 subcategories to a quad. In fact, there's actually 3, which we're not going to see the third. But parallelogram is one of the main ones. A lot of people always talk about squares and rectangles. Parallelogram is pretty much the shape you're thinking of. And then the other word is called a trapezoid. Those are the 2 main ones that everyone really thinks about with quads. I said there is a third category, which we'll see in like chapter 5. But we're not going to talk about that now. Most people wouldn't understand it. Okay, but every four-sided figure does not have to be one of these two. Like, these are very special cases of a four-sided figure, and including that third one that I'll show you later on. But a parallelogram, by definition, just so you know, a parallelogram has where it's all the walls are parallel. So I always use the pink pearl eraser as my example. I'm using this little shadowed edge, that the top and bottom are parallel, and then the sides are parallel. So opposite sides are parallel. So I'll let you write that down. Draw the picture. Okay, so opposite sides are parallel. Top, bottom, right, and left are parallel. It's pink pearl eraser. It kind of looks like a rectangle, it's not. It's kind of like bent sideways. So I always use the pink pearl. The other one was the trapezoid, right? Trapezoid only has one pair of sides are parallel. In fact, here's the picture of the trapezoid. Here's the trapezoid. This I always use this picture. Oop, geez, I gotta back that up. That's a trapezoid. It kind of looks like a skateboard ramp, or if you look really close, like if you use like a razor, like a shave, if you're going to shave with a blade, that's like what the shape of a blade is. The thinner it is, the more sharp it is. That's a trapezoid, right? It only has one pair of sides are parallel. One pair, so it's usually top and bottom. That's usually how we look at it. I know, like a lot of times they always build these door wedges for classroom doors and doors at home. Like you put a little piece of wood under a piece of under the door to hold it open. That's the shape they always use. It's flat. Top and bottom are flat. The sides usually are tapered. Tapered means to lean. That's a trapezoid. These are probably the two most common shapes that you'd see in nature, because they just support a lot of weight. Ramps are usually trapezoids. If you're going to go up to a ramp to like a loading dock, they usually have a trapezoid sitting there. All right, next. Under parallelogram, there's two categories. So these are the ones that everyone thinks of. When I said, hey, give me a four-sided figure, everyone's like, oh, rectangle, square. Those are the types of parallelograms, where the sides are parallel. The rectangle is one of them, and the rhombus is the other. If you mix those two together, that makes the square. The square is the weird mix between the two. Rectangles, by definition, it's a four-sided figure, the walls are parallel, but it has four right angles. You can actually see the angle markers. Notice now all four walls are equal, just it has 90-degree angles in the corners. If it's a rhombus, this little blue one down here, if you're not colorblind, but that little blue one there, that's a rhombus. Rhombuses don't have right angles in them. What makes a rhombus special, the top and bottom, right and left are parallel, right? It's a parallelogram, but all the walls are the same size. So if you actually look at my picture, all four walls are equal. It kind of looks like a square, but I stepped on it. So it's bent. That's a rhombus. But again, if you mix both definitions, where it's a four-sided figure with the walls are parallel, where you have right angles and all the walls are equal, that's what makes the square. It's the most special form of a quad. It's actually called the regular quadrilateral, because all the walls are equal, all the angles are equal. And again, in chapter 3, I think it's chapter 3 and 5, we start talking about the properties that are involved with all these. We go through one shape at a time, we talk about properties that we use. Okay, now we go to the trapezoid. Trapezoid, where the sides are parallel, here's that shape I gave you earlier, that little skateboard ramp. It only has one subcategory. There's one special case of a trapezoid. It's called the isosceles trapezoid. Here it is. Same thing, it looks like a skateboard ramp, but what makes an isosceles equal is that the word isosceles, we saw earlier with triangles. Isosceles means two walls are equal. That's what happens here. It has two walls that are equal, and the top and bottom are still parallel. These are the quads you probably see. Now there's that special third category that we're going to see in chapter 5. They're called kites. They have certain definitions to them. If I were to throw them up here, they would look too much like the other ones. So there's a special definition for it. Okay, questions on the different polygons. Now, there's two words I want to discuss here. when you talk about polygons, quads, triangles, pentagons. They're on your practice guide, when we were doing vocab the other day. It was the word perimeter. This is something we're going to be going into, right? This is the next chapter, chapter 2, we talk about perimeter. Perimeter is the distance around a polygon. It's the distance around. Distance around a polygon. So something with straight edges. If you have curves, because you can still find a perimeter of something with curves, right? It still has an outside distance. If it's a curve at all, that's called circumference. They pick two different words because those are two different types of shapes. So circumference is the distance around a curve. Curve or circle. Why they have two different words for the same meaning, right? They still talk about the distance around something. Because polygons have straight walls. Those are easier to calculate. So polygon, perimeter, right? P and P, they start with the same letter. Circumference and circles, they start with the same letter. That's how it works. Now eventually, for both of these shapes, for polygons and for circles and stuff, we'll talk about area. Area is like how many square tiles can fit on the surface. So like this room has area, it's how many tiles are on the floor, basically. There's volume or area or volume to an object if it's three-dimensional. This room has volume, has airspace. So those are the terms we need to discuss. But I want you to know these definitions. The reason why is that people have a misconception. They think they're the same. Like, oh, I'm going to find the perimeter of the circle. The circumference of a circle, the distance around. These are just easy vocab words that we can discuss. We don't need to know the formula for them yet. But they're just words you need to know. So I'll use them when we start talking about these polygons. All right, questions at all? Perfect. All right, take out your practice guide. Stop the camera here. All right, talk about your practice test.
Now we'll get better.
You better go quick. All right, so practice guide. Let's have it out. I'm going to pop it up here in a second. So we didn't have too many words to go through today. Okay, we did vocab yesterday. We walked through all those terms. The video, I'll make sure it's online today, so you can kind of go back and watch those. But you have a question?
Yeah. Okay, so is obtuse an angle whose measure is greater than 90 and less than 180?
Yes.
Okay, so then what's the one with the decimal?
The same one. It can be used
They're
twice.
both obtuse?
Yeah.
Okay.
That was, obtuse was used twice. I think it was supplementary, and it was supplementary, and I think the perimeter wasn't used.
They weren't?
They weren't. Okay. There's two words that weren't used, and obtuse was used twice. Typically on a test, I don't do that. On here, I just did it. I'll kind of warn you if you're going to use a word more than once. And if you're not going to use a word, I'll kind of warn you of that. Usually the first test, there's always one word you won't use. But I'm giving you the idea what could happen. But on yours, it's going to be pretty straightforward. The people who really study their book, read their book, look at the vocab words, the ones that are highlighted in yellow, will be fine, because that's the words I picked from. Okay? All right, let's move on. I'm going to go through this pretty quick today. I'm not going to do every question. I said that. We're just going to go through, I'm going to highlight things that you should probably know, types of questions. Like this is what, question number 2? I'll pick a new picture from your textbook, and I'll ask you a series of questions on it. Now, if the picture's really faded, like I know yours is faded, right? It's hard to print a 3-dimensional picture on, a flat 2D picture. So if you need to, make sure that you have these planes drawn. These are individual planes. They look like pieces of cheese. Boom. There's your planes. Make sure you highlight those. They are basically parallel to each other. They're like railroad tracks. What I want you to know here, and I'll always warn you this on test day, the line P that's going right through these, line P, or if you want to call it DC, line DC, if I put little arrows above it, that's poking through them like this. It's poking through. The two planes are going through. So point D is way up in the air. It's like the top of my marker here. It's not on the plane. M, I know this is deceiving, M is not on that bottom plane. M is the middle of my marker. It's floating in the middle, it's not on that bottom plane. Does that make sense? I'll warn you on test day of that, and how you know why it's poking through. It has dashed lines. So I'll kind of warn you on like test day, I'll put the pictures up there, and I'll highlight them and I'll go through the directions before you start. If you don't pay attention to me going through directions, you'll miss stuff, because I'm going to give you maybe some freebies sometimes. Alright, name the lines that are only in plane Q. Plane Q is down here, because remember, they can use the cursive letter system to name planes. Preferably, if you name a plane, you write the word plane, you put a bunch of letters behind it, unless you use the cursive letter. Then you can just call it that, plane Q. What's a line that's on plane Q? N. Line N. And don't write line NQ, or what, NG, I mean, NG. N is the name of the line. If there was another dot on line N, G and maybe H, you could call it GH with the little arrows above it. But since there's no other points, you can't just use the single letter. So you have to use the cursive letter. Line N. What's the other line? Q. So you can write line Q. Or if you're not that person that likes to write line Q, you could have wrote HL, and you have to have the arrows above it. I'm going to check if you're using the right number of letters, if you're using the arrows. If you forget that stuff, I count it wrong. You can miss an incredible amount of points on number 2. Because you don't want to put arrows, you don't know how many letters you're supposed to be putting, you're not putting the right item down. You keep writing the word line in front of everything when it's not asking for that. So, there's many different ways you can answer these questions. Some of these are very open-ended, there's many different answers. How many planes are on that picture drawn?
2.
2, you already know that question, it's 2. Name a plane that contains line M and T. What's the plane over there?
R.
Plane R, that's one name. Call it plane R. Or you could call it plane, what? A, C, E, F, B, like you can just call it a bunch of different letters. These are the same name to me. But notice, you have to write the word plane. If you don't write the word plane, I count it wrong. That's how it works. And if you use more than 3 letters, you're fine. But it has to be 3 or more letters, not in a straight line. I think plane R is probably the best. Name the intersection of M and T. Where did M and T meet?
Point C.
Point C, thank you. Finally, somebody's actually doing that correctly. It's point C. That's good. You have to write the word point. If you just write C, I count it wrong. You have to have the word point in front of it. It's an actual location. It's a dot. It's a vertex. That's a point. Another name for T?
EC.
EC with the arrows above it. Good. Line EC. The arrows. If you forget the arrows, I count wrong. Can't just put a bar there. There's actually arrows. Okay, we're good with number 2. I will have a picture, a new picture, and a series of questions about it. It'll be basically the exact same format. Like the same types of questions. Name this line, name this plane. What's this point of intersection? What is it called? It'll be something obvious. I usually try to pick a pretty decent picture. Something that's kind of easy to look at. Like this is kind of the tough one. This is kind of over preparing you for what you're going to see in your test. It usually can be pretty simple. Okay, number 3, you have to find distance. The ruler will be there for you, so you don't have to borrow a ruler from me. Nothing's worse than 90 kids trying to borrow rulers from me on test day, trying to figure out how to measure stuff. It'll be something either with metric system or US. This is the US customary system, it has inches. Your answer better be labeled in inches. And it looks like it's going by 16ths. How I know that? If I count how many hash marks there are, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, yeah, 16 you get to between the inches. So my answer will be in 16ths, probably. Okay? It looks like if I'm going in 16ths, I definitely made it to 1 inch for sure, so I have a big number 1. And now the fraction behind it is out of 16. And if it happens to be simplified, I'll simplify it later. This is the easiest way I can train you how to do this. You count how many marks you have total. I had 16 marks to get to the next marker. And it looks like I'm landing on what, number 14 you said? So I'm landing on 14/16 of an inch.
And or 7.
Yeah, or you can simplify it so you don't have to memorize the ruler system. If you simplify the 14 over 16, that's 7/8 of an inch because you divide both numbers by 2. That's probably the easiest way I can train you how to do this. If it's the metric system, maybe it's in centimeters. It's whatever mark you're at. So if you're at the 7th mark, it's maybe whatever inch or centimeter you're at. Maybe you went past the 3rd centimeter, but you're at the 7th mark. That's 3.7 centimeters. Because whatever mark you land on the metric system, that's the decimal that goes after it. So 3.7. If you're at the 8th marker, 3.8. But you just have to look at what marker you fell at. For inches, it's easy. You know it's going to be in 16ths. If it's not in 16ths, just count the markers. That's the number that goes on the bottom. That's the easiest way I can train you how to do it really, really quickly. Okay? All right, let's keep going because I got to get through a lot of these and I'm going to go quick and quick. 4. You have to draw the picture. I'm going to only do one of these. Which one do you want me to do? Top or bottom one? Top. You have to draw the picture on this one. The picture is the same for both top and bottom. How I know the picture? They're describing how to draw it. It's a segment where y is in between z and x. Here's x and z, and y is somewhere in between, I don't care where. Y is in between x and z. I'm going to label my pictures. X, y is an 11. Y, z is a 4c. And it looks like the whole stick, x, z is an 83. If you don't label your picture, you don't know which two parts to add. Because when I look at that picture, which two parts should I add?
X, Y, and Y, Z.
Yeah, because when you look at the picture, you add the two small pieces together and that should equal the big piece. If you don't label your picture, how do you know which ones are which? Some people are really good with the letter system, but what if I put the letters out of order on test day? What if I say A is in between B and C, just to mess with you? So be careful of that. So now that I know this, and you're going to have to do the same for your bottom one, because there's two separate problems, I'm just doing the top one right now. I can add these two together, and that makes the 83. So 11 plus the 4c equals 83. And then I can solve. I can subtract it over, divide, and you get your answer. Right? So it's 72 divided by 4. What is 72 divided by 4? It's a 2, no, it's 1. What is it, 18, something like that? 18. So C turns out to be 18. And then you have to plug it back in because they wanted you to find what your variable was. And then you have to plug it back in to YZ. So I have to plug it in back here. That's 72. If I plug in that 18, 4 times 18, which is 72. And that's your that's your YZ. I'm going to plug the 18 back in after I solve for C. And it tells you in the directions which one you have to plug it back into. If you don't draw the picture, I almost guarantee you'll get both of those wrong if you don't draw the picture. Because you have to label it and solve it. Questions at all? Okay, I'm moving on. Hopefully you got those down. I said I'm moving quick today. Okay, number 5. You're finding the distance, the distance between things. You're finding the measures of J, L, and KP. That means you're finding the distance. You can count with your fingers, or you can do the formula. The formula will be on the board on test day. Here's your formula. You take and you subtract the two numbers, whatever the endpoints are, and that gives you distance. If I ask for midpoint, so you have to read the directions. Midpoint is where you add the two together, whatever the two endpoints are, and divide by 2. There's a clear difference. Do I want the distance, or do I want midpoint? I want distance. I need the number between, the distance, the measure between them, finding each measure. And I'll warn you that on the test day, which one I want you to find. So it looks like I'm finding distance. So from J to L, here's J, here's L. My endpoints are -7 and -2. So I'm going to plug those numbers in. -7 minus a -2. And yes, I always subtract whatever the two numbers are. So even if they're negative, I'll subtract them. So if I subtract, that means I'm adding this. So that's -7 plus 2, which is -5. And what's the opposite value of -5?
5.
5, that's your first one. There's 5 bunny leaps between J to L. Duh, count the sticks. There's 5 sticks between them. If it was asking for midpoint, I want the dot right in the center of them, which is what? 4? No. 4.5? -4.5?
Yeah.
Like the number in between if it was finding midpoint. Okay, questions at all how to find distance? Okay, distance on number 6. How to find distance on number 6. I don't know if we'll have time to finish this today. Push test back to Monday. Okay, this will be my last one today. Tomorrow we'll pick up from here. That way we won't take tests tomorrow. We'll take it Monday. That way everyone gets a fair equal opportunity to study. So you got lucky. All right. So to find distance, ooh, mine got cut off. Do you guys have the numbers on yours? What's that bottom one?
-2, -3.
-2, -3. So it is just going by one, so 2, -3. All right, sorry, mine got cut off by the weird line in the middle. All right, so whatever yours are, and you gotta find distance. The distance formula will be on the board, here it is. So distance is equal to, you subtract the x's, square it, you subtract the y's, you square that. And that's all under a big radical. This will be my last one today, we'll pick up from here tomorrow. Okay, so to subtract the x's, the x numbers for my coordinates are the front two numbers. So the x ones are these numbers, the 4 and the -2. I'm going to subtract those numbers in any order I want. So I'm going to go 4 minus the -2, because I don't care the order I write them. And then the y's are the back two numbers. That's the y and the y here. So 0 and -3. So I'm going to go 0 minus the -3, because it doesn't matter the order I subtract it. I can write them in any order I want. Okay, so 4 minus the -2, that's 4 plus 2, which is 6, and I'm going to square it, that's 36. 0 plus 3, which is 3, we square it, that's 9. Because squaring means you take it times itself, right? That's how I'm getting these numbers. And then when we add them, we get what? The square root of 45? And that's the number I'm looking for. That's my distance. Now what the square root of 45 is, if you type it in your calculator, it's like 6 point something. 6.8, 6.7, something in that range. So that's the distance. What that means is how many sticks fit between these. It's about 6.7 sticks between M to N, I guess, or whatever those are. Again, does everyone know how to type that in your calculator? How to type in radicals? If you don't, that's something we need to figure out tomorrow for sure. Okay, it looks like we're going to take a test Monday. If you have any late work for me, get it turned in. Get it turned in. I know some people just didn't have names on papers. That's fine. That's easy fix. Okay, it looks like we're taking a test Monday and tomorrow. We'll pick up right here at what, number 6? We'll continue on tomorrow. Somebody just turned in a page 50 in the back. Page 50 in the back. You sure? Gonna go in the recycle today. That's another one without a name on it.